So, is the centrifugal governor amazing or what? Um, the reason I include it here is it's been a favorite machine of mine for most of my life. When I first learned about this, I just thought it was the coolest thing going. And the reason is because it it represents one of the first integrations of safety and human control into a machine. So think about how steam engines work. You basically build a metal canister, a metal can of some sort. You fill it with water and then you heat it up, and it generates steam. And that steam has it gets pressurized, and so it can move things. It can change heat energy into mechanical energy. The early uses of this were to create pumps that would be used to take water out of mines, because it turns out that flooding mines is not a great thing for trying to get mining done. And what you do if you had a steam engine, right, is you'd have somebody who paid very close attention to how much pressure was there, and they would know what the pressure limits on the canister were. And when it got too high, they'd either release some steam or they'd take the heat away. If you did an experiment in your kitchen, you could take a pot, fill it with water, put on a very, very tight lid, and heat it up. And at some point, if you weren't careful, you would have a bomb on your stove. The pot would blow up and people would get hurt. And so you'd want to have some way to be paying attention to how that system is behaving and to intervene when necessary. So if you think about our description of automatic machines, right, you need a sensor, you need something that can measure how much pressure is there. You need to be able to compare that against some standard. And then you need to have an actuator which will release the pressure or take away the heat if necessary. So the thing that's amazing about the centrifugal governor is you're taking that expert operator who can pay attention to how much pressure is there, and you're building it into the machine so that once you set that governor, what you've got is something which, when the machine threatens to explode because the pressure is getting too high, it slows it down, it lowers the pressure, it releases some pressure, right? Or it cuts down the fuel, so there's less heat going in. And similarly, when it falls below a certain level, it can top it up and push it forward, right? So basically keeps it operating within a safe range. Now, the connection to this course, if you remember back for the course trailer, we started and we said we're going to make our way on a trajectory that starts from learning to think slowly. We want to end up being able to participate in conversations about beneficial AI, about safe artificial intelligence. Artificial intelligence, we can think of it as automated reasoning, automated decision making. And what we're looking for when we talk about safe artificial intelligence is governed artificial intelligence in the same sense as the governor on the steam engine. We'd like to think that when we have a robot, we have a machine learning algorithm, when we have artificial intelligence, that we can keep it operating within limits of what humans consider desirable and beneficial. And so the seed that I want to plant with this in this session is to be paying attention to the idea of governance and feedback in automation, because those are going to be key to the way that we think about how artificial intelligence works at all, and in particular how it is that we might build some structure into AI that would act as a kind of governor that would allow us to know that it's not going to blow us up.